Okay, looks like we are live. And today I'm streaming from Windows to see if there is any difference. But first, let me make sure I am streaming. And yes, I am. Okay, we're gonna see if it is any different with Windows because with Linux the experience wasn't very pleasant. Cool. So we are going to continue the MQTT implementations that we left for that. Is here. You have to set up. I have to set up the SSH key, otherwise I have to type every time. Let me just double check. What? Okay. Is it visible? Fonts? I'm guessing not. Cool. Let me just double check how it looks here. Look shit. And right now it's terrible. It's like so washed up. Ever. We were somewhere here, and we were around MQTT in code. Yeah, we are here. So we are going to continue after this, right? So we basically encoded. Now I'm guessing there is some decoding, which is today's topic. To do says handle a case where multiplier is greater than this value. I don't know. What is long? What did I do about this long? MQ encode MQTT. I did not do anything. What is this unsigned long? An unsigned long occupies 8 bytes of memory. It stores an integer from 0 to this, which is approximately blah blah blah. And is it any difference? No. 8 byte means 64 bit. Cool. So it's saying we have 64 bit MQTT decode length. We are decoding length of the past um, pointer to a pointer. Hmm. 64. What do you have? Oh, it is in the MQTT header. This topic. Yeah. Instant unsigned pointer to pointer, which is same as this. Now, how do I decoding it actually? That's just written in that. It's written in some. Why is my time? Okay. Cool. I think it's going to take me some time to sink in actually. And get in line. So what are we doing in decode? In decode, there is this character, some multiplier. Now I say that this is your value. I dereference the buffer, so basically I get the first value, whatever this buffer points to, I get that first value. I hope I remember this from the last discussion. That why, uh, not the discussion, it was the more or less the explanation of why this thing leads to the first value. Now in this is fine. So, I take the and I multiply it by a multiplier and I add it into the value. What is it doing? Without putting a concrete example, I don't think I'm going to understand this. I feel like not doing anything, but this is why I stream, so that I do what I feel like not doing. Where is it, my Excalibur? Man, the event bus stream is also been pending for quite some time. What is this? This is some callback registry. What is this? What did I do? Huh? Callback registry, event ID. This looks like some event bus thing. Anything else? No. Oh, I'm on Windows, so this is probably from a long time ago. But I'm like, how do you create a new canvas? Let me just search it. Canvas in XLETRAW. No. When I open gallery, I show the last canvas is worked on. I want to create new one, blank canvas, but can't seem to the option to this. Okay. You can clear the canvas using the trash button. Cool. Very hard to use with the local sync changes done lately. I cannot open two different Excel drawings in the same browser to copy paste them. It is actually not possible to have two different drawings open at the same time at all. I really don't understand the issue which leads to this. This is an intentional change so that all tabs sync the data and user never ends up losing drawing due to getting overwritten by latest one. What the fuck? Closing this as it's resolved. We will open it. Okay. Since you merged the PR back in January, I cannot have several independent Excalibur tabs open at the same time. The issue of lost drawing was something I discovered early and easily managed to work around by not doing it in that way. For me, the current implementation is even worse. I open a tab with Excalibur, draw and drag what 42? Being forced to use just one canvas at a time, then saving the deleting the current one, then creating a loading a new one is just a bad UX. Through that, let me create multiple independent canvases. Even if we introduce an internal tab system inside the app for switching between canvases, this way the browser tabs can still be synchronized, but Accelero can have multiple available. I believe this also relates to this issue. I came to both of these issues from Google looking for a way to. Me too, bro. Me too. Where is the trash button? Are you kidding me? You seriously couldn't give the new button now? Or like you said, if like okay, if I open oh fuck, it indeed is just what the cool. This is not something that I want, bro. Okay, this is bullshit. So let's get back to coding, or more or less. Yeah, so you're saying that I basically first I have a buffer with just so I have this buffer and this is nothing but a value. So forget about even buffer. I just say that this is some value. A character. So I'm guessing 0 to 255. Let's just say some number. First delete this. I just say that I have some number 20. And now I say take and with that 20, what does it that give me? Programmer's calculator. So I say that 20 and with 127. What did 20 give me in binary? 20 is this. 127 is probably just setting this bit. Right. So 127 is no setting all the bits except okay. So from this character you essentially extracting the, like I said, like initial 7 bits, and then you multiply that by a multiplier which is in this case 1. Then this becomes 1 and the value becomes, wait a minute, if I'm ending it this, then whatever the if this is 1, if this is 1, then uh, if the value has 1 in it, then it will be 1, and if the value has 0 in it, then it will be 0. So whatever the value, so it is like that Boolean law that we studied. X time and with 1 equals to x. No matter, like, deciding factor is x. Now if x is 0, this is 0. Maybe let's call it y, or maybe let's write it like this: y is equals to x, and okay, not y, it is x actually. So if I say x and 1, the result will always be x. And I'm writing it wrong, bro. This always results in x. You get the point. I don't know how to write it mathematically, correct mathematically. So whatever my x is, the result is x. Okay, so I just understood. So the thing is, you just you said, and let me just write this again. Now if I say this, then this would result in 0, right? No matter what I put the value for x, it is always going to be 0, the result of this. So that's how you just removed the 0th part. I mean, I can put whatever in here, whatever value, but this is going all to be always be 0 because because of this 127, right? Everything is 1 else except this part. So if I multiply that by 1, then this becomes a value which is 0 plus whatever c. So it's currently working like, how do I write this? Interesting. I'm thinking. C is a character, so 0 to 255. Well, not 0 to 255. C is a character, so 0 to minus 128 to 127, something like that, bitwise. And so whatever value C has, all the 7-bit values, multiply that by 1. This gives you bitwise, multiply that. 128 will lead to 0. 127 take and to, it is going to be 100. So 127, 128. What is 129? That's 1, because of this. This bit gets 0 and all I remain is this. So if this gets 127, 128 means 0. 129, 130. Like, for example, what is 130? This 2. So this is like starting back from 1. So 29, 127, then you say 128 becomes 0, 129 becomes 1, 130 becomes 2, and so on and so forth until you have all these. Decode. Okay, this makes sense because in encoding, the last bit, the 8th bit, does not indicate data, right? It indicates continuation bit. So by keeping this value, whatever inside this buffer is, by keeping that value capped at 127, ensures that I don't include the last 8th bit, right? But then you have a value which is value plus some number, 127 multiplied by some multiplier, right? Initially, let's just say I say ki my value is 120. I take and with 127, which is going to be 120. So this becomes, initially this is 0. So this becomes 120 and I multiplied this by multiplier which is 1, and this becomes 120, right? Then I say that multiplier is, then I say m is equals to 128. This is for the first value. For the next value, I run this, I take the value out, value will become my current value, which previous value, which is 120, and I add, well, let's just say my value in this case, the character is 10. I AND it with 10, which would I AND it with 127, which would essentially mean 127 multiplied by my m. M is, at this case, it was previously it was 1, but now you multiply it 128, so it would be 128. This is 120 plus, this becomes 10 multiplied by 128, which essentially becomes 128 plus 1280. That becomes yeah, this is right now. Okay, so this is like 120. This would mean 0, 8, 9, 10, which is again 0, 3, 4, 1. Cool. 80, 20. It becomes 13, and then 100 becomes 14. Now this is my new value. I think I see the pattern because this is a multiplier. It is saying like this, the initially the whatever this value is, it's at first offset, like initially. Then you said that it move by next value would be multiplied by 128. It is like essentially the what we do with decimal like 10 and things like that. No, it is similar thing. But why is it saying handle a case where multiplier becomes greater than this? So this is essentially increasing the head. It is a pointer to head. This would increase the head, like we previously discussed. It will do this until this last bit, 8th bit, is not equal to 0. Until then you keep doing this. I think I get the idea. You can start implementing it. Why it is doing so. So we'll first take a character for whatever reason, I don't know. Then we take multiplier is initially 1. Then we take unt 64t, which is 0. Now we'll say do this, get the value, and now you say now calculate this value, which is C, and now exclude the continuation bit from there and multiply the multiplier. In the next step, multiplier itself gets multiplied by 128 because why not? And then I move the head so that the next time C gets the value of the next thing in the buffer. Right, okay, so dereference buffer and plus plus it. And do this until the continuation bit itself becomes 0, right? Until it is not 0, keep doing this, right? So it all depends on continuation bit. To be honest, I still don't understand this part. I have a feeling that it is why it is there. I have a feeling, but you know the programs that reverse the number or reverse the string. It is exactly the same concept here. I just don't feel like recalling that because I don't feel like I should do that, but not today. I'll do that sometime later because it's going to take a lot of time. And right now I feel like moving forward is more important. That's all. Well, now we read the first header byte and yeah, and the total length of the packet. Let's move on with the unpacking of the connect packet. It is the packet with more flags and the second one in length behind only the published packet. It consists in a fixed header with MQTT control packet type 1 on the 4 most significant bits and unused fully significant bits. The remaining length of the packet and the variable header consists of the 4 fields: protocol name, protocol level, connect flag, keep alive. Let's move on with the unpacking of connect packet. The string, its offset, and the length will not be changed by future versions of the specifications. Protocol name MQTT, 4 bytes in total, will be ignored for now. What is the name for older versions? Connect flag byte contains some indications on the behavior of the client and the presence or absence of fields in the payload. Okay, makes no sense to me. The last bit is reserved. Cool. All other flags are intended as booleans on the payload part of the packet. According to those flags, there are also the corresponding fields. So let's say we have username. To clarify the concept, let's suppose okay, now we are going with the example. Cool. Receive a connect packet with username and password flag to 1. This Username is this, password is this, client ID is this. Now what? Packet type is of course one. Okay. What is this? Oh, no, not gonna implement that. Just too nerdy for me. I was about to read this sometime. Inventing the service trait. You do that sometime, huh? Tower is a library of modular and reusable components for okay service trait. Not today's, tomorrow's problem. Okay, so the packet type is one offset byte. I don't know what that means. What the hell is happening? Connect type length is one. 32 byte length being it requires no sense, man. Like, from where do I start this? What is the starting point of all this? I forgot everything. Where is the official documentation? What are we having in the connect packet? Where is non-normative example? Control packet type, which is variable header. Okay, so fixed header is pretty much covered. Like the LSBs are going to be reserved and MSB will control packet type of this, which has a value of 1 if I remember correctly. Oh, this was the case that he was talking about. Is greater than malformed remaining length. Throw an error. How do we throw an error? Why is it cut it out? This is same, right? next byte from a stream, value plus encoded byte multiplied by multiplier. Okay, so you don't multiply it here, you first throw it error. I can probably handle this via some sort of, like, in my encode example, I'm returning this 64-bit, but why do I returning 64-bit? Where and is a bit was school, value contains the remaining length, terminates value contains the remaining length value. Okay, so I was not looking for this. The connect packet is 1. In this case, this variable header, this is pretty much like we can make sure we are right by looking at this. Yep, connect packet is 1. And now all of this is fine. I'm looking for a non-normative example of variable header. So variable header is this one. See, every packet has a fixed header and a variable header. So if we are talking about this connect type, packet type, then fixed header is covered. Inside variable header, protocol name is going to be like this, protocol level is going to be like this, and sim connect flag, clean session, etc, etc. Now we'll see what this non-normative header, variable header non-normative example means. This is a simple example of containing a variable header, of a dummy variable header. So the protocol name will contain, okay, so it is only 4 bytes, so this will contain like 4 bytes, which is 0, 1, 4, like 1, 2, 4. So this one is set. This is M, UTF encode is string, so MQTT, this is pretty much covered, not going to change ever. Protocol level going to be 4, don't know for which reason. Okay, so this is byte 1, byte 6, byte 7 is protocol level, and byte 8 is any of this. Byte 9 and 10 are keep alive. So I'm guessing this is how it should be in my packet header of type connect. MQTT connect, MQTT connect. So MQTT header is pretty much fixed, pretty much self-explanatory. Did I pronounce it right? Pronunciation. I mean, and these streams are not fun, right? They are boring streams. क्या ही कर सकते हैं भाई इसके बारे में अब. See, this is what happens when you give too much gap between two streams. Now I'm just revisiting everything. I just don't remember properly. Okay, so this is how you address. So every header has retain duplicate type. Okay. Last 4 bytes type or initial 4 bits. Last 4 bits are type and initial 4 bits are reserved for my guy. Next, so initial 4 bits are reserved, last 4 bits are of packet type 1. So this is why just this. And then I take a union of these things, which is a single byte. And I say the first one is reserved. But why? Let's look at the byte 2 is remaining length. This is a non-normative example here. So you are saying this is reserved. First is clean session. 8th bytes now, byte 8. And how does it will QoS? Are you going backwards? Username, password. I think is going backwards. I don't know, maybe I don't remember correctly, like what is the order of this. Like this is a byte 8 clearly. Okay, so protocol name is fixed. Level is like byte 7. And we are talking about, this is union, this is struct. We are talking about a byte here. So I don't know, man. Let's move forward. Packet is 1 byte. 1 packet type is 1. We just saw it here. And packet type is 1 because of connect packet type. And the length is what length? I don't know what length is talking about. 32 bytes length. Being it less than 127 bytes, it requires only 1 byte. Protocol name is of 2 bytes. Byte position, which is 0, 1, second, fourth, MQTT makes sense. Protocol level is 1. Connect flag, word will return QoS flag, and clean session connect flags. Did any of this mentioned? Protocol name? Protocol length, packet type, length. What is length, man? uh, Protocol level, protocol name length. Oh boy, which is 2 byte, makes sense. Yeah, it is here. Protocol length 2 bytes. Then your protocol name, which is MQTT, size 4 bytes. This guy. Offset is 3. Yeah, 4. Then comes your protocol level, which is this one. Then comes your, which is of single byte. Then comes your connect flags, which is your byte 8. 8th byte. How does it add here? Um, 1 byte, 2 byte, 3, 4, 5, 6, 7, 8. Now they are pointers, so their width varies. Connect flag, then your keep alive, which is of 2 bytes here. Bit 1 of connect bytes flag. Bit 1 connect flags. Clean session. Will flag is bit 2. Oh, so that's why it is reserved, because it just says that it is reserved, but it doesn't mention anywhere, right? So will QoS bit 4 and 3 and 4. Will QoS 3 and 4 यानी कि 2 bit का remain 5th bit. That's pretty straightforward. User flag, username flag, which is bit 7. 8, 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7 bit. 1, 2, 3, 4, 5, 6, 7. Sixth is password. 1, 2, 3, 4, like 1, 2, 3, 4, 5, 6 is password, and 7 is username. Pretty weird, man. Then comes your keep alive, which is of 2 byte, byte 9 and byte 10. And before that, this is a byte 8. This is a byte 7, byte 1, byte 6. Okay, so if it is starting from here, LSB to MSB, that means this is bit 0, bit 1, bit 2, 3, 4, 5, 6, something like this, right? Okay, so okie dokie. Okay, so this is at position 0, reserved. This is 1. No, this is not position, this is value. It reserved is 0. This is 1, 1, 1. This, and username flag. Keep alive. That means LSB, MSP. So it's starting from, okay, so the dude was nice. Nacho. काहे नाचे भाई? Having will flag to 0, there's no need to decode those fields, as they don't even appear. We have a result We have as a result a total 34 byte packet, including fixed header. Don't understand this. Like here, it's saying this function was static, so and it makes sense. And I'll simply write it like this. I won't change the name because if you're saying it's static, then it should not appear here, right? Maybe I'm missing something in that case. But I feel like did not understand something from here, so I'm missing something. Having will flag to 0, there's no need to decode those fields. Having will flag to 0. What is the will flag? What does this say about will flag? We think we have to read this. Connect flags. So connect flags byte contains a number of parameters specifying the behavior of the MQTT connection. It also indicates the presence or absence of fields in the payload. Okay, so that is why you don't need to decode those. Understood? Server must validate that the reserved flag in the connect control packet is set to 0 and disconnect the client if it is not 0. So what do you mean by clean session? Okay, so connect flag. So that's why. What does these flag mean? Start with clean session. Position. Okay. Byte 8. Wait. 1, 2, 3, 4, 5, 6, 7. Oh, these are two. I'm dumb. Okay, this bit specifies the handling of session state. Specify the handling of session state. What do you mean? The client and server can store session state. The client and server both can store session state to enable reliable messaging to continue across a sequence of network connections. This bit is used to control the lifetime of the session state. What is a session state? to the lifetime of session state. Makes sense? Does not make sense. If clean session is set to 0, the server must resume connection with the client based on the state from the current session as identified by the client identifier. If there is no session associated with the client identifier, the server must create a new session. If clean session is set to 0, that means the server must resume communication with the client based on the state from the current session. Oh, so okay, so it is like this. So if the clean session is 0, means whatever the session state that the server has, it doesn't need to start another session or another clean session, right? So it can resume whatever its current state is, session state, and serve the client. It doesn't need to create a new session, right? This is what it's saying. If there is a no session associated with the client, only then the server must create a new session. The client and server must store the session after the client and server are disconnected. Client and server must store the session after the client and server are disconnected. So they must store the session somehow. After the disconnection of session that had clean session set to 0, the server must store further this and this messages that match any subscription that the client had at the time of disconnection as part of the session state. Okay, so the client gets disconnection, then whatever subscription the client has, and if those subscription messages have QoS, quality of service, greater than 0, then server must store these messages as part of session state. It is like this, that a session is session could be, I'm just thinking here. A session could be a collection of some data, right? Session state, we are talking about state here, so it is some data, and whatever that data is, just add messages whose quality of service value is greater than 1, because that means they are like, right, you know what QoS is. So whatever the subscription that the client had asked the server to, whatever the client subscribed to the MQTT break server, and if those subscriptions has these messages with these QoS, then they also get stored as a part of the session state. It may also store queue message that meets the same criteria. Fuck off. If clean session is set to 1, the client and server must discard any previous session as expected and start a new one. Makes sense. This session lasts as long as the network connection. State data associated with this session must not be reused in any subsequent session. Nice. The session state in the client consists of, see, here it is, the whatever the data that state consists. QoS1 and QoS2 messages which have been sent to the server but have not been completely acknowledged by the server. QoS2 messages which have been received from the server but have not been completely acknowledged. The client did not acknowledge to the server that it has received these type of messages. They will be part of session state of client. A session state in the server consists of the existence of session, even if the rest of the session state is empty. Client subscription is messages which have been sent to the client but have not been acknowledged. messages pending transmission to client, messages which have been received from client but have not been completely acknowledged, optionally messages pending transmission to clients. Cool. Retained messages do not form part of the session state in the server. They must not be deleted when session ends. Retained messages. What the retained messages are? For details and limitation of stored state. When clean session is set to 1, the client and server need not process the deletion of state atomically. Non-normative command. To ensure consistent state in the event of failure, the client should repeat its attempts to connect with clean session set to 1 until it connects successfully. To ensure consistent state in the event of failure, the client should repeat with attempts to connect. Okay. Typically, a client will always connect using clean session set to 0 or clean session set to 1 and not swap between two values. The choice will depend on the application. A client using clean session set to 1 will not receive old application messages and has to subscribe afresh to new topics that it is interested in each time it connects. Fair. A client using clean session set to 0 will receive all QoS1 or QoS2 messages that were published while it was disconnected. Hence, to ensure that you do not lose messages while disconnected, use QoS1 and QoS2 with clean session set to 0. Okay. Clean session set to 0. What I understand from this is if you have set this to 1 clean session, then in case you get disconnected and you try to reconnect, you will start from the scratch basically. So if you care about that you hold that you don't lose data, right, then you set it to 0, which I think in most cases is going to be unless it is only some sensor data like some telemetry thing, then I don't care about if I lose couple of packets. When a client connects with clean session set to 0, it is requesting that the server maintain its MQTT session state after it disconnects. Client should only connect with clean session set to 0 if they intend to reconnect to the server at some point later. Yeah, that's a good point. When a client has determined that it has no further use for the session, it should do a final connect with with clean session set to 1 and then disconnect. Oh my god. This is good. What is will flag? If the will flag is set to 1, this indicates that if connect request is accepted, a will message must be stored on the server and associated with the network connection. What is the will message? The will message must be published when the network connection is subsequently closed unless the will message has been deleted by the server on reception of disconnect packet. What is the will message, bro? What does the will message do? No idea. Then the will message must be set to 0. If will flag is 1, then the value of will QoS can be anything. Will retain. What is the will, man? Rest is, I guess, pretty straightforward. So unpack MQTT Connect. Let's just type something pretty quick. Oh, okay. My bad. This is MQTT unpack packet. This is unpack MQTT Connect. Okay, so that was different. That was different. So, like I said, I'm not a fan of function prototypes, so I'm gonna implement it here. What do you say this? Okay, this is your unsigned character buffer. This is your header. This is your packet. Uh, Unnamed prototype parameters. You should have given that error in function prototype, bro. What the fuck? This is your some buffer, MQTT header, packet. This is your packet, and now what are you doing here? You are creating a MQTT connect packet with header as the value header. QTT connect packet as whatever the value of header is. What are you doing? Like, I don't understand this part. MQTT connect. What does it do? Is it anywhere written there? Yeah, operational behavior, storing state, network connection, security, using web sockets as network transport, conformance target. What do you mean by conformance? Mandatory normative statement, non-normative. Need diagram in 4. Oh, QoS0 protocol flow diagram. I just see what is it. Sender action is this control packet. That was shit. That was shit again. What do we have here? What do we have here? At most, anything related with the initial behavior, maybe somewhere here. This is talking about storing states. So network connections, quality of service level and protocol flow. I think this is where the block is handy. So what are you doing? Okay, so let's just first understand what is it doing, then try to implement it. And this is good. Fixed header. This one is fixed header, right? What happened to my mouse, bro? So you are essentially creating a local copy in here. Connect will have more than header, right? Mqtt connect, which is this one. So the header one is you copied. Okay, so there are other fields also. So you said that header is something that you create like this. Okay. Now you say that, okay, so you are unpacking from this buffer. Okay, what is MQTT packet again? If I recall correctly. Okay, so MQTT packet is a union of any of these things, which is could be an egg, header, connect, publish, subscribe. Okay, so packet, MQTT packet. Packet, packet, and connect. Okay, so it is like a general packet, right? So like packet could be header, packet could be connect. Understood, I guess. So you're giving me header from, and I said, what is the packet? Like, is it an out parameter or in parameter? Now you say packet connect. So packet has connect. Okay, so you are already unpacking this one, right? So you know what kind of packet it is. So you are saying, okay, so this is your out parameter. You are putting data out, and this is your in parameter. This is also your in parameter. So data is coming from this and this, I think, into this. You create a connect packet, then you say that this is a connect packet. So you said that packet dot connect equals to connect. Then you said in it. Okay, so buffer is of single pointer, but why in this case it is a single pointer? Okay, you copied that. Decode length. Second byte of the fixed header contains the length of remaining bytes of the connect packet. Okay. MQTT decode length. What am I doing in decode length again? Decode length, you pass in that from address and I don't get it. Whatever that buffer was, you just took the address, made it a double pointer, which is fine. But what exactly are you doing? Not concerned with how, I'm concerned with what. So you're saying that second byte of fixed header second byte contains the length of the remaining byte of the current. That means something like this one, right? Second byte. But when did you? Okay. Second byte of fixed header. This one contains the length of remaining bytes of the connect packet. So you says address of this buffer MQTT decode length. So you decode this until you get your continuation bit 0. This is how this is written, right? So until the continuation bit, the 8th bit is not 0, you keep decoding that. I should put somewhere here if multiplier is greater than 128 multiplied by 128 multiplied by 128, it's an exception. Handle it somehow. I think my fonts are pretty thin. 350 isn't going to cut it. This has to be normal. Eh, $360, is it any different? Nope. $350 makes it I guess it is 350. It is. The continuation bit. What will I? The remaining length is the length of the header. First length of it is good in the matter. Okay. Protocol bytes. Somewhere it was said that connect packet. Oh, the connect packet does have a variable payload. Does it have a variable payload? Payload is required. Payload is required, buddy. Cool then. So you decode it. My problem is here. It shouldn't it pass the second byte? Let's just say it passed the very first byte. Then I take it and okay. I don't know. So you are essentially saying that I'm getting the second byte. I'm decoding the second byte and getting the length. For now, we ignore checks on protocol names and reserved bits. Just skip to 8th byte. So init plus 8, which is pointer arithmetic, I guess. So now you say that buffer is this. Read packet.connect.byte. Check on protocol name and reserved bit. Okay, this is protocol name, and we jumped and protocol level onto the 8th byte. And 8th byte is what? 8th byte is this, I guess. Cool. So I said that unpack U8. Address of buffer. Typecast it into this. Why would you do that? Like, isn't the address itself is sufficient? I don't know. I never understood the typecasting to to prevent errors. How does that work? I mean, from integer and something I understand, but like my point is that the function here, when you say unpack, my point is when you say it, in this case, this, which is unpacking. See this. So wouldn't the call itself would consider it like this? I don't know, man. So you are doing what here? I don't know. Okay, so you saving the initial state because this is going to modify that pointer. Like it is going to modify this buffer thing, the address that it contains, which is of some pointer, which is of um, some. And you say incremented by 8 and pass it to unpack it. From there, you get the first byte, which is your header byte flags, means 8 byte. These are flags. Then you say read, keep alive MSB and LSB 2 bytes. So you read 16. So from there, and you say that connect dot payload dot keep alive. Uh, Payload dot keep alive. Inside variable header, byte 1. That means if he's saying byte 8, eighth byte, that is eighth byte. This is ninth byte, bro. From there, you get this keep alive 2 bytes. After that, the CID 2 bytes. What is that? Client ID. Okay, so how would the payload look like? Like variable header has only 2 bytes, and there it is. So this fixed headers, second byte tells me how many bytes are there in the upcoming variable header. You get the whole byte, get the payload and keep alive. Then you set client ID of 2 bytes. Client ID is greater than 0. Then you say connect.payload.client ID. But where it is said that the client ID will be in payload, I think it did say the payload of the connect packet contains one or more length prefixed fields whose presence is determined by the flags in the variable header. These fields, if present, must appear in the order client identifier individual client. So each client connecting to server has a unique ID. The client ID must be used by clients and by servers to identify state that they hold relating to this MQTT session between must be in present and must be first field in the connect packet payload. First field in the connect packet payload, and I see it is second. Okay. Must allow client IDs are server must allow client IDs which are between 1 and 23 UTF-8 encoded byte in length, 1 byte or 23 bytes that contains only characters of these. Okay, I think I got it. The connect packet, if the client length, which is, I'm guessing the first 2 bytes. Like, where is this information, man? My goal of whole this doing this is that I should be able to extract the information by reading the docs itself. Like right now, wherever this information is coming from, I don't see it in the docs. Server unique client, blah blah blah. There is no indication of 2 bytes. Cool. You get the client ID length. You said that client ID is for the null byte. Unpack bytes. From this client ID. Read the will topic and message if will is set on flag. Connect dot bits. Where did you get the connect thing? It was no, it's in the packet. The whole byte is variable header byte flags. Variable header, like you're jumping it. That means you are essentially coming onto here. Right, by doing this and this. Unpack 8 bytes from this buffer. Now, okay, so let's just say that this says unpacked 8 bytes, which is this whole thing. Now you say that unpack 16, which is this thing, keep alive. Now you said unpack 16, which is 2 bytes, which I'm guessing if it isn't, it is a connect packet, which is this one. Then you got that byte, which means this whole thing. And now you saying that connect packet, which is your payload. Inside this payload, okay, inside this payload, nothing. So I'm guessing this is your flags byte. After that, 2 bytes are your keep alive. After that, you have client ID, sorry, client length, which is of 2 byte. Then you are essentially saying that packet with client ID is, then you are unpacking bytes from this buffer, this many bytes into this location, which you just mallocked here. Now you say that if the will is set, which you already took from the 8th byte, this one, you're saying if this is 1, that means you are taking the string from this buffer into this will topic and into this will message if the will is set. Otherwise, if the username is set, then you are doing again 2 byte password, then you are doing 2 byte same thing, and then you return length unpack size t. Well, let's just say, so first thing first is your connect. What is this connect? Okay, so this is connect. So you say that my packet.connect is equals to connect. But why? I don't know, man. Let's just move forward. Next, you save that initial pointer, and but why constant? Okay, so data is constant. Second byte. When did you read actually the first byte? This is my point. When did it read the first byte from here? He's saying second byte. I understand it is, but when did you increment it? And did you decode length? Which is, what do you require? You require address to buffer. So I got the length of the remaining byte header. Sorry, got the length of the remaining bytes. Now I skip through this part, skip the check on protocol name and all that. And this thing is incremented by 8 bit, which is, now I say, now I read the read all those flags, will flag, etc., written flag. Packet dot, huh? Unpack, it's of 1 byte now, so U8. From where? From address of buffer. No, I'm not gonna typecast. Just looks ugly to me. Because its type is already this. So when I take the address, it becomes that type. I don't need to invent it. Next thing is I get that keep alive thing, which is of 2 bytes, which is payload. Payload? Why it is a payload? Inside payload, I have keep alive. But where is it defined? Fixed header makes sense to me. I'm just looking for that payload header which says that the client ID has to be there. In case of published packet, this is the application that requires payload. This required payload. Publish is optional. Subscribe and these guys require payload. Fixed header is pretty much fine. Variable header is also fine. Where is the payload has a client identifier? I mean, that is why does payload have keep alive? Wait a minute. A payload of connect packet type contains one or more length prefixed fields whose presence is determined by the flags in the variable header. So if it is length prefixed, that means client identifier, which clearly means that initially it is the length, then it is the client ID. But I'm still don't understand why I have this in here, keep alive. Why? Maybe sometime later makes sense. Cool. The keep alive is what? The next 2 bytes. But why am I putting it into the payload? What I'm doing here, I'm doing unpack. I just don't understand. There's too much. Unpack 16 bits from this buffer. Keep alive. Then you have client ID length, which you are storing where, not any time. Client ID, you say it is your, you say if it is greater than 0, what do you do? You क्लाइंट आईडी, भाई क्लाइंट किसने लिख दिया? Client ID is malloc client ID, which should be of pointer of what? Why is it a, it's mqtt.h. Why is client ID? Why is client ID of pointer to unsigned date? Okay, so it is, seems like is perfectly fine. What is the size that I have to? It's apparently client length, bro. Okay, +1. Understand. And shouldn't I check if there is enough memory available or not? Maybe not. Now what do I do? From this buffer, I get the client ID at this location. So unpack 2 byte. If it is, then unpack 16. Unpack string 16. Right, from source and destination, which is, what is the source? Source is your buffer, bro. Wait a minute, it did said like init. Where did it use init? Somewhere down the line. Did ever use the init? Okay, so it is used init here itself. Okay, so source destination. But did it use source destination? This is different, man. Oh, so you are unpacking bytes, not unpacking string. My bad. Unpacking bytes size. See, this is why I need things here, man. Who the fuck? The data is going from where to where? So copy this many bytes from this buffer into here. And the client ID length, this many bytes into my client ID PSEKT. What is next? Next, we'll read the topic bit. Will. If the will is 1, then we read 16-bit string from this buffer. So I'm creating the packet, this one. But why am I calling this packet an MQTT packet? Could be a pointer to if my will bit is set, which is packet.connect.bits.will, then I'm unpacking string 16. From source is my buffer and destination is my payload. Will topic, right? And do PIC will message. What is next? Next is if the username is 1, then I copy username. If my packet dot connect dot bits dot username is set, then I unpack string 16 from buffer is the source and destination is again Okay, so I'm creating the payload here essentially. Cool. Same goes for, I think, username password field. Unpack 16, source is my buffer, destination is my packet dot connect dot payload dot pss password. Right, so similarly is nothing, rest is done, just return length. But where, like, how is it a second byte, man? Yeah, I this was passed in here until and unless this was passed in by the second byte. Uh, the publish packet now. Let's suppose we create a connect packet with username and password flag to 1. Username is hello, password is hello, client ID is danzan. Packet type is definitely going to be connect. Fixed packet type. Then the length is 1. 32 bytes length, being it less than 127 byte, it only requires 1 byte. Oh, so it is of that remaining length byte thing is coming from there. It is only 32 byte length, so that's why only 1 byte is required. Protocol name and thing like this is all good. Connect flags are only size is this, and offset, these are going to be connect flags. Then you have keep alive, which is 2 bytes. Makes sense. Maximum value is 18 hour, 12 minutes, 15 seconds, 16-bit word. Then you have client length, then client ID, username length, username, password length, password name, like this one, length prefixed fields. So that's why you have length prefixed every time. Having will flags to 0, there is no need to decode those fields. Okay. Okay, now I understand what he means. So if we are creating a packet, connect packet of this with this data, then the will inside this connect flag, this will flag being 0 means there is no topic here. And if that is the case, then we don't need to decode those fields. Like I understand this one. So maybe you are passing the sec from the second byte here. This is the only thing that I can make sense. So the publish packet now, which is this is your bits. So this is your fixed header. by 2 to 5. These are remaining length. Variable header is topic length MSB LSB 56. Topic name is 8 to N. Packet identifier N plus 1 2. Then the payload is packet identifier are present in packet if and only if QoS level is greater than 0. With QoS set to at most once, there is no need for packet ID. Payload length is calculated by subtracting remaining length with all the other fields already unpacked. I think the next stream we'll be able to finish this. I guess so. Unpack, subscribe, publish. So we're done with this. Next is this guy. Of course, encode length and decode length. MQTT unpack connect message and decode length. I mean, this is probably not necessary at this point. I'm just copy pasting that blog. Done with the MQTT connect, unpack MQTT connect. For fuck's sake, man. What the fuck, man? I'll do that later. Okay, so next stream we'll continue from this. Okay. See you, boys. Bye bye.